Okay, everybody, how's everybody doing? I am down at the track getting ready for a track meet. So if you guys want to come on down and watch our track meet, that would be awesome. And if you want to help out, we'd love to have help too. Okay, so that's today around 4 o'clock. All right, let's do the lessons. So 4, 26, 19. So here's what we're going to do today. Today we're going to do other quadrilaterals. So these are not parallels. So we're going to call them special quadrilaterals. Okay, special quadrilaterals. And the reason they're special is because they're not parallelograms. These are not parallelograms. Okay, these are not parallelograms. So let's go ahead. And you guys did a little bit of reading. So I'm just going to summarize our reading. So here's what we had in our reading, our journals. We talked about trapezoids, isosceles trapezoids, and we talked about kites. Okay, all of these two figures are definitely quadrilaterals, four sides, but they are not parallelograms. So first of all, define a trapezoid. Okay, so let me just draw one. Hopefully you guys saw this in your book, but I'm going to kind of paraphrase and go back over what you should have read. So let me find the one. Okay, here we go. Here is a trapezoid. Let me draw it on the side. Okay, so what makes it so unique? Okay, only one thing. This thing only has one special characteristic, and it just has one set of parallel sides. That's it. So it is a quadrilateral, with one set of parallel sides. Okay, nothing special about it at all. There's no congruencies. There's no congruent diagonals. It's just, that's it. It's kind of a boring figure, except for the fact that these two are parallel. Okay, but once we make it an isosceles trapezoid, we get some things from it. So let's change it now from a regular trapezoid to an isosceles trapezoid. Now, if it's going to be an isosceles trapezoid, it's got to have two equal sides, and these are called legs. Okay, these are called legs. So what makes it an isosceles is that it is an isosceles. So it's a trapezoid with one
all right, members of the class of 2020, all members of the class of 2020, please head to the conference right now for pre-scheduling.
Congruent sides, and we call those legs. I don't know why we call them legs. I really don't know why they're called legs, but let's call them legs, okay? So what's the special characteristics? Well, first of all, the biggest thing is that we can know, and we've read this, is that we're going to say base angles are equal. Base angles are congruent, equal or congruent, okay? So let me mark my figure. Here we go. So that means this angle is congruent to this angle. Cool. And then, believe it or not, if we're to draw the trapezoid like this, these are also could be considered base angles. So this angle is congruent to this angle. So if you draw it upside down, it really has congruent angles here and here, and these are also base angles. So it is kind of funny because you think, okay, it's got base angles and top angles, but they're both called base angles. Okay. What else is unique about isosceles trapezoids? Well, let's see. The diagonals are congruent. All right, so we draw my diagonals. So my diagonals from here to here. These two line segments are the same length. So if I label this A, B, C, D, we could say that AC is congruent to BD. Right? Now a kite. We all know what a kite is, but how do we define a kite? Well, first let me try and draw one. They're kind of a little tricky to draw. I don't have a little template. I wish I had a little template for it, but I don't. So I'm going to try and draw a kite for you. Let's see. Let's go there, there. I'm going to go up there and down there. So here's what makes a kite. It is a quadrilateral. A quadrilateral, okay, with two sets of adjacent means next to, adjacent means next to, two sets of adjacent congruent sides. So let me draw it in. So if I'm going to draw a kite, then this side is equal to this side. Right? I mean, you know that if you're looking at a kite, and we've maybe built kites before when we were kids. Well, you guys are kids. But I could say those two sides have to be equal if it's a kite. And let me draw on the rest of it. This side is equal to this side. Now you guys can have the substitute pause the video anytime if I get going too fast. I'm trying to pace it just right. Give you guys a chance to catch up, okay? So that's a kite, and that makes sense. It kind of looks like a kite. Now what makes a kite special? Well, just a couple of things. One, the diagonals, okay? So let's talk about the diagonals. The diagonals are perpendicular. All right, that makes sense. I don't know if you've ever built a kite. I have as a kid. You know, that was my childhood, is we built kites, and then we knew that the pieces of wood, the sticks that built a kite, went like this. So when you buy a kite at the store when I was a kid, they had these little kits, and you have these little sticks, and these sticks always went together like this, so the diagonals are perpendicular. They go at 90 degrees. That makes sense, doesn't it? Okay, what else? Well, one other characteristic about a kite, and that is we know in a kite that it has one pair of opposite congruent angles. One pair of opposite congruent angles. That angle is congruent to that angle, okay? These are not equal. The long, skinny one is not equal to the top angle. The tail angle is not equal to the head. So if you made it a kite, right, there's your kite flying. The tail is not congruent to the head. But the two side angles are always going to be congruent if it's a kite, okay? Now, are these two figures parallel? No. Trapezoid is not a parallelogram. No. They are not. There's no parallel sides. Well, I take that back. There is one set of parallel sides, but not two. So it's not a parallelogram at all. That's what makes these things so special, okay? All right, I'll give you a second, and I'll flip the page. There we go. All right, now, example 1. Find, so in kite, A, B, C, D, find all the missing angles. We can do this, right? First of all, before I even start on this problem, I'm going to put right here 90 degrees. Make this, that is 90. I'm going to make sure I do that, because if it's a kite, it's perpendicular. That's going to help me with this quite a bit, okay? All right, so here's what I know. If it's a kite, this is 24, this is also 24 degrees, okay? Because that gets bisected, okay? And of course the book didn't say that, but on these two angles do get bisected. That's equal to that. That one's equal to that one, okay? So if I go back to my figure, 24, 24, if this is 58, this is also 58 degrees here, okay? Those are congruent. Now, how do I find the rest? Well, I can find, let's find this angle right here, okay? And I'm going to look at a right triangle. So if I go ahead and highlight my right triangle right here, I can find angle AD. Oh, let's make this E, point E. How's that? Let's make that point E. So if I want to find angle ADE, angle the measure, I want the measure of angle ADE, I'm going to go, let's see, that's 90 there. I've got 1, 2, 3. All three angles add up to 180, right? 3 angles. So I'm going to go 180 degrees minus the sum of my 24 and my 90. Or I could have just gone 90 minus 24, but we're going to learn that one later. That's just kind of a shortcut on that thing. So I use my calculator. If I go 180, or to shortcut, it really is just 90 minus 24, which is 66, okay? Shortcut it. I know 90 is left over. These two have to add up to 90. That's my shortcut. Okay, so 66 degrees for this angle, which means this angle is 66, okay? Now, let's get this angle right here, which would be angle BCE. So the measure of angle BCE, the measure of angle BCE. Same thing. Let me highlight my triangle so you can see it. All right, there's my triangle I want to look at. And I know in a triangle 180 degrees, but we're going to shortcut it. If 90 has already been used, let's use some common sense. If 90 has already been used, then these two have to make up the other 90. So I'm just going to go instead, I'm going to go, okay, what's 90 degrees minus 58 degrees? And that's going to give me the other angle, because those angles are complementary. So if I go 90 minus my 58, I get an answer of 32. So this angle is 32 degrees. So 32 degrees, and of course this is also 32, okay? So the trick to this is to make the 90 and then find, in a sense, 4 right triangles, okay? I made my 90, so then I find 4 right triangles I can go ahead and complete, okay? All right, example 2. In example 2, what I know is if it's an isosceles trapezoid, then I know angle A is congruent to angle D because they're base angles. And I know angle B is congruent to angle C because they're base angles. So I know that angle B is congruent to angle C because they're base angles of an isosceles triangle. So what I want to do then is set their measures equal. So I'm going to go 10, oops, it's bad looking 10x plus 4 is equal to a 5x plus 24. And I'm going to solve. Okay, got this angle equal to this angle, angle B. Angle B is equal to angle C. Angle B is equal to angle C. So we're going to solve. Minus 5x minus 5x. 5x plus 4 equals 24. Minus 4 minus 4. 5x equals 20. Divide by 5. Divide by 5. X is equal to 4. Now, all right, we're not done. That's not the answer. It says find all interior angles. Okay, so let's go ahead and put a 4 back in. Oh, if I put my 4 right here. Okay, so I'd go, all right, let's see, what is 5 times 4 plus 24, okay? So I plug my 4 in for x. And that's 20 plus 24, which is 44 degrees. Okay, so this is going to be 44 degrees. Well, angle B's got to be 44 degrees also because those two angles are going to end up to be congruent. So this is also 44 degrees, okay? Now, angle A and angle B are supplementary. Let me write that down. Supplementary, meaning they'll add up to 180, okay? So that means they add to 180 degrees. That's supplementary means, okay? All right, so that means that angle A, so if I go to find angle A, I want to find the measure of angle A, I'm simply going to go 180 minus 44, use my calculator, all right, 180 minus 44 degrees, and I get 136. That does not make sense. Well, I'll fix this later because this should be the 136 and that should be the 44. All right, I'll fix this later.
All right, would members of the class of 2021, all current sophomores, come down to the Commons, please? Again, class of 2021, all current sophomores to the Commons, please.
All right, there's the announcement. Anyway, I probably need to rewrite this because this 10x plus 4 should be here, and 5x plus 24 should be here because that looks more like 44 and 136. That's all right, no big deal. The math is still the same. So if I were to rewrite this, not to confuse you, sorry about that. I probably need to go rewrite this thing, but I should have drawn it like this. I'll show you. I should have drawn this problem like this. And I will fix it. I should have put the 10x plus 4 here, and I should have put the 5x plus 24 here. I still get an answer of x equals 4. I still plug it in, and I would have gotten 44, but 44 degrees makes much more sense to be here and here, and that 136. Oh well, no big deal. I'll fix it later. Trapezoid mid-segment theorems. So what we're going to say is this. We're going to say that it's an average of its bases. average. So how do you do an average? You add them up, divide by 2, right? So if I have a mid-segment, I know it's got to be a mid-segment because that's a midpoint and that's a midpoint, okay? And what I can do with it is find the value of x from lengths EH, FG, MN, okay? So my guess is I've got my EH, my FG, and my MN if I label this, okay? So let's find the value of x and the lengths of all of those. So I'm going to do it this way. I'm going to add my bases. So I'm going to add this base plus this base. I'm just going to add them together. Base 1, so I'm going to go EH plus this base, which is FG. It's an average. This base plus this base divided by 2 should equal my mid-segment, which is my 6x minus 4. Okay? All right, let's do that. So EH is really 2x plus 22 plus, that's my first base, plus this base, which is my 6x plus 6 divided by 2. So I add the bases. I go, okay, I've got my 2x plus 22 plus my 6x plus 6 divided by 2 equals my mid-segment, which is my 6x minus 4. Okay? Now, let's go ahead and try and simplify this as much as I can. That's going to be an 8x plus 28 divided by 2 equals 6x minus 4. Okay? Now, divide by 2, I'll have a 4x plus 14 equals a 6x minus 4. All I did was I divided 8x by 2 and 28 by 2. So I just divided them both by 2. Okay, now I'm going to solve. All right, I'm going to get rid of the smallest x. Minus 4x minus 4x. 14 is equal to 2x minus 4. Plus 4, 18 equals 2x. Divide by 2, x is 9. Okay, hopefully I didn't go too fast with that, but I added the two bases, I divided by 2, and then I solved. So x is 9, but we're not done. That's only part of the answer. So let's plug that back in. So let's plug it in. So if I plug 9 up in here, so 2 times 9, I'm plugged right there. 2 times 9 is 18. Okay, 18 plus 22. Let's see, check it out. Okay, 2 times 9 is 18 plus 22 makes a grand total of 40. So this side is 40. Okay, let's plug it in here. Let's plug my 9 in here. What is 6 times 9 minus 4? 6 times 9 minus 4, and I get an answer of 50. This is probably 60, but you know, it seems like an average, but we can plug it in. It's got to be 60. 6 times 9 plus 6. 6 times 9 plus 6. 54 plus 6 is 60. What do you know? There it is. And we don't need the journal because we already did earlier. So that's what I have. You have a homework assignment and you have an exit ticket. Do your work, put your cell phones away. And that's all I have.